What's up everyone, my name is Andrew Fung. Welcome back to another hands-on tutorial that helps you learn programming through building interesting projects like this one. So today I'm going to show you how you can do targeted keyword tracking or analysis based on the advertisement displayed upon each Google searches. So the main idea for this video is actually the following, and I'm sure a lot of you also have your own set of keywords that you're concerned with, whether it is your area of interest, whether it is maybe your boss wants you to do a competitor analysis based on the popular advertisement keywords. Either way, you would like to figure out the big players behind those set of keywords. So for example, my list of keywords contains crypto, NFT, which is gaining a lot of hype last couple of months, and also smart contract like blockchain and Web 3.0. And I would like to know who are the big players or who are the top companies that are behind these keywords. So all I need to do is click run, and it will do a simple web scraping to scrape the top ads and also bottom ads, and that will hopefully help us in determining who are the big players or who are the top companies that are allocating huge amount of advertising budgets on these keywords, on purchasing these keywords to appear on top. And while it is running, I can show you how does the web scraping program works. So what we can do is go ahead and right click and click inspect element. So essentially the web scraping task is about figuring out the pattern. So when we take a look at the first part, I believe the first part, we can see a section called with the ID TV cap, and also for the bottom we can see for example here it is called bottom ads. So basically the whole BeautifulSoup thing that I've mentioned in the last video is just figuring out these two diffs and then scraping those advertisement of their essential information. For example, the company name, which is the most important thing, the product description, and also the selling or the advertisement title, etc. So going back to our program, some of the keywords does not contain any advertisement around it. For example, Web 3.0, it is basically a concept or an idea, so there won't be any physical company that are purchasing these keywords to appear on top. And you can also specify the number of times that each keyword is run. So for example, you can change it to 100 times, and that will hopefully remove the bias in the randomized nature of Google advertisements. So without further ado, let's get started. Let's go ahead and import some packages. Let's import requests for making GET requests from Google, and LXML for parsing the BeautifulSoup, JSON, time, and also TLD extract, which we'll be using it to extract the domains from the companies. And also from BS4, import BeautifulSoup. We did it last time in our web scraping video. So let's go ahead and first specify a user agent. So you may ask, what's the point of having a user agent? Basically, a web scraper by default does not have a user agent, and that is very suspicious for web servers like Google, and they will instantly identify you as a bot because we do not provide data about a user. So it is much better to add this extra step and start using a library of user agent if we want to gather data efficiently. Now we can list our own keywords that we're concerned with. So we can start off with NFT, and also maybe cloud computing services. And the number of times that we like each keywords to be run to remove the bias. So this time would be 10. 10 would be a good starting point. So we can now go ahead and do get request from Google based on our search query. So HTML equals request.get https www.google.com/search, and then question mark Q equals. So Q stands for query, and we will provide it later. So the params will be equals to payload, which we'll be defining later, and also the headers. So from here, headers equals headers. Payload, we can define it before doing the get request. So payload equals Q. So Q stands for query, and let's set the query to be the first keywords inside the list of keywords, so 0. So after getting the HTML, we can get the response, set it equals to HTML.text, because we are just interested in the text part of the HTML. And we can parse it using the soup, so soup equals BeautifulSoup, and then put in the response text, and then we parse it using LXML, and then we can later on print out the soup, and we can make sure that we're getting this HTML file based on the search query of NFT, and we can save it to check it out later. So with open output .html ws file.write string soup, and that should save a file of output.html. And let's go ahead and run this to see if it works. So beware that these classes name will change, but the entire structure won't change. So if you're watching this video maybe 2 years later, you might actually have to change the class name or the tag name, but the overall structures won't change. So you just have to look for these specific tag names. So let's go back to it, and we can see our BeautifulSoup printed out and a new output.html. So we can download this and see. So let's click output, and we can see our Google search of NFT, and we're actually getting some ads from the top section and not the bottom sections. Okay, so let's move on to the next part, which is scraping the top section and also the bottom section ads, and with their information such as the company name, the product description, and also the advertisement title. So we can do this by using BeautifulSoup. So we can find top ads, make it equal to soup.find. So we are looking for an ID, which is a TV cap. So here I've just shown you that we're looking for this TV cap ID. So ID equals TV cap, and then so if it exists, so if top ads, and then we'll find for container in top ads dot find all. So after we have gone into this div, TV cap div, we'll be looking for each advertisement entry. So this will be this class div, the div of this class, which is UEIERD, and we're looping through this. So we can do, we're looking for div and the class name, which is the one that we just copied. So let's do try. If there is a advertisement title, so advertisement title equals container.find. So we'll be looking for the div with the class name equals this one. We will then go on to find its span and the text, extract text from it. So if there's none, we do an accept, and we set the advertisement title to be NNA. Moving on, we can find the company by doing a top container.find. We'll be finding div as well, and the class name equals to so the top section will be this part, so this tag, and we'll look for a span with the class name equals this part. So we're basically extracting the URL from the advertisement and then extract the text by it, and that will hopefully print out the link. So we can do more as well. We can extract the product description, which will be a similar fashion. So container.find, we'll be looking for a div with the class name of, so the product description here is this class name. So copy this and then extract the text from it as well, so we can print out product description. And this to move it down, and then also print out the title as well. So print advertisement title, so we can loop through. So for each advertisement we can leave a space by printing a new line. So let's go ahead and run this. Yep. So let's clear the outputs, and for this time nothing prints out because there is no advertisements. So we can run it again, and let's see. So this time we got advertisement, three of them actually. So we got NFT art by Nifty Gateway, NFT payments by Circle.com, and also this company Gemini. I believe it's Gemini. So this company that we've printed out, we're not actually getting the company name, but the hyperlink only. So we can do something called domain extraction, and that's the reason why we imported this library TLD extract. So we can under company, under the link that we've extracted, we can set company equals to company, actually it's TLD extract dot extract company dot domain, and that should take care of the problem. So let's run this, and this should show us the circle.com, circle, and also Nifty Gateway. So that works. Moving on, let's take care of the bottom ads. So this would be a similar process, just the top ads and bottom ads are different by the ID name. So let's set bottom ads equals to div with the ID bottom ads, and then if bottom ad exists, just print out the these information as well. So when we run the whole thing again, we can do print a new line with top ads. So top ads, and let's copy this line for bottom ad starts. So let's move it down to here. If it exists, then we would do the following things. And then we also need to change the top ads to be bottom ads and run this for a couple of times by doing a for loop. So for underscore in range, number of times, then we put everything, indent everything, and also this part where we save the HTML. So let's go ahead and run this and see if it works. So we mostly got a lot of top ads. So let's just change the list of keywords to be more popular keywords for ads. So maybe loans, insurance, and yeah, something like this. Okay, so it shows that the top ads and bottom ads does work, and we can move on to the next step. Okay, so now we'll be creating a result dictionary to make sure that we have got all the information that we need whenever we want to figure out the top players for each keyword. So for a quick idea, we'll be looking for companies with for a number of times of running the web scraping script. We'll be looking for which of the advertisement has been the absolute top, has been in top section, and also in bottom section. So the companies which are appearing on top for absolute top for the most number of times. So we can do that by creating a result dictionary, an empty dictionary. And then let's go ahead and make sure that the, for example, for the HTML request, we have to make sure that it is a valid request with the correct status code. So status code equals HTML dot status code. And for those who are familiar with HTML status code, we want them to be 200 to ensure that it is a valid request. So if status code equals 200, then we will proceed with the scraping. And then this too, this part. So after we have made sure that it works, it is a valid request with the correct response and status code, then we will move on to doing a for loop for each of the keywords inside this list. For keyword in list of keywords, let's go ahead and indent this part and also this part, and then we will change this list query to be simply keyword. So before we run each loop a number of times for each keyword, we will first create an empty company list. so that for each successful scraping of advertisements, we'll put the respective company into the company list, and if it does reappear, we will rank up the scores of the absolute top and also bottom section score. We can actually move this keyword to be outside this loop, and then so if after we have fetched the company name, we can go ahead and set a if statement. So if the company is not in the company list, then we will append the company into the company list, append the company name, and then for a result dictionary, for this company, we will first create a keyword, which is, for example, here, insurance. There will be a insurance element inside this resultant dictionary, and then there will be a key with the company name, and we can set this equals to a new dictionary with the elements of absolute top equals to 0, top equals to 1, because it is inside this top ads section. So for bottom, it will be 0 because it's not in the company list yet, so it's the first time it appears. And then else, if the company is already in the company list, meaning that it already has a key inside this results dictionary, we can then go ahead and go to keyword company, and then go to top, and then +1, plus equals 1. Okay, and we do the same for bottom, so we can go down to the company side of things. So it will be bottom 1 and top 0 because it is not inside the company list. And for bottom, we will go ahead and add 1 to it. So given that the top advertisements and bottom advertisements are random in nature, we would like to monitor how many times does advertisement come up for each keyword. So we can monitor this by setting this results if the length of this result, so it will monitor how many advertisements are in top ads. If it is larger than 0, then we will add 1 to the number of top ads. And we haven't defined this yet, so we can go on to top equals 0, and the same goes to bottom ads. So if we can copy the exact code for bottom, so if the inside bottom advertisements there is no advertisement, then we can set the bottom ads to be 0, and if it is larger than 0, then we will add 1 to it. And after we have done scraping with the keywords, we can go ahead and compute the number of times for each keywords, and I believe it's 1 more indent, so result dict, the total top ads will be equals to number of top ads, and bottom will be bottom. So we can put this inside and actually move this on top, and then you can print the resultant results dict in a JSON format. So JSON.dumps results dict, and then sort. We don't actually have to sort the keys properly. We will set the indent equals 4, and let's see how it goes. So let's clear this and run. So we haven't defined the key insurance yet, and set the result key equals to result dict. So we have to instantiate the keyword first before we insert any element inside the dictionary. So we have to define an empty dictionary for the keyword here, and that should do it. Okay, so we got the dictionary results. So for loans, so let's talk about the insurance. We find like these companies with the top and bottom stats. So actually for the absolute top, we haven't defined it yet. So we have only added one to the top and also bottom section for the company list. So we can go ahead and check. So let's go ahead and run this. So bear in mind that we only manipulated the bottom and also top advertisement only. We added one whenever we detect like the company is not inside the company list. If it is, then we add to the results dictionary. We haven't defined how we get the absolute top. So now we will actually go ahead and look at the dictionary, resultant dictionaries. We see a lot of companies inside this keyword. We see Progressive, Insurify have these kind of companies. We don't know which company is the top performers or which time they rank most on they rank highest in absolute top. So then we can define the absolute top to be first 0 before we scrape any advertisement entry on top. So if the logic is if the company is not in the company list, then append the company in the company list. And if the absolute top is equals to 0, then the result we will actually go ahead and append 1 to absolute top and set top to be 0. And else it will just be a top. And the same goes to the else statement. So if the company is in the company list, If the absolute top is 0, then we append this. If the absolute top is 0, then we go ahead and find the absolute top attribute, and then attributes, and then +1. Else we will just add it to top. Okay, and after this we will then add 1 to absolute top. And for the bottom part, we don't have to actually care for this because there is no metrics for absolute bottom. So and for result dict, we actually need to append the keyword inside, so it should be 1 layer in. So keyword equals number of top ads. Yep. So let's go ahead and run this, and it does seem to work for now. And while this is running, we would like to do one step further, which is actually creating another attribute, which is based on the order of influence or the top performing companies. Right now, when we take a look at the result dictionary, we actually see a lot of companies for each keywords, but we have no way of ordering them or seeing their performance. We see a bunch of metrics based on their performance. So we'd like to go ahead and create another attribute. We can set it to top performers. For each keyword, we will find the keys, which are the company names here, and then sort them based on the absolute top. First the absolute top, then the top, then the bottom. So how can we do that? We will first need to get the keys. So keys equals to list of results dictionary, and each keyword, and dot keys. So that will gives us the company names for each keywords. And then inside keys, for name in, so bottom, top, and absolute top, we will sort them by keys dot sort, and then key equals to a lambda function. Okay, we set k to be result dict keyword. So this dictionary, we will sort them by the name, which is bottom, top, and absolute top. So we will be sorting by name, and we will set the reverse to equals true, so that we'll be ranking for example progressive to be the top because it has the most appearance on absolute top. So after that, we can put keys into this top performers and see which are the top performers. And now let's go ahead and change this list of keywords back to those keywords that we're concerned with. So NFT, probably crypto, and maybe Bitcoin. Let's see. One more thing to note is that we can actually add some buffer time in between the web scraping so that the server won't find us very suspicious, as we're fetching a huge chunk of data within a short period of time. So between top and bottom ads, we can add some buffer time. Time.sleep. We can sleep for maybe 4 seconds, maybe 3 seconds. And then let's add one more printing line for visual purposes. Yep. So let's go ahead and let this run for a couple of minutes. Okay, so looks like we got the results. The results are outputted in the console, and when we take a look at NFT, let's investigate on top performers. So at circle.com, Nifty Gateway, we can actually check the ranking and see if the top performers sorting is correct. So let's take a look at circle.com. So circle.com, absolute top is the most 7, and for Nifty Gateway, so it has a top for 7 time, and for the third one, the Story Exchange is top for 2 times. And we can actually analyze, like, for each keywords, we can take a look at the total number of top ads. So out of the 10 times that we scrape, we can of course increase this number by maybe 100, 1000 to remove more bias based on the random nature. We can see that the top ads appear 70% of the time whenever NFT is searched. So that's pretty much it from me for this tutorial. Hopefully you guys learned something new about how you can do Google advertisement scraping based on the keyword and do simple comparative analysis based on the list of keywords that you are concerned with. So for the next video, we'll be turning this script into a more dynamic and user-friendly web application using Streamlit, so that whenever the users want to do their own competitive analysis for the keyword, they will just need to type in their own set of keywords that they're concerned with, and then set the number of times by a slider. And in terms of the discovery and also insights that they see, instead of a static list of top performers which does not highlight individuals' metrics and also their performance, we'll actually address some of the questions like whether it's worth to put advertisement on this keywords that is maybe not that popular, and whether our competitors are actually ranking top on these keywords that we would have been ranked on if we allocate budget on that. And stay tuned for this video. If you enjoy this type of content, make sure you smash the like button, subscribe, and also turn on notification bell so that you won't miss any of these videos like this one. Thanks for watching, and see you guys in the next video. Bye guys.